Welcome to the next set of video notes in our Sequence and Series chapter. This one is our introduction to series. So when you take the terms of a sequence and add them all together, the result is called a series. So a series is really just a sequence where you added everything together. For example, if I am given the sequence 1, 2, 4, 7, 11, 16, if I change it into 1 plus 2 plus 4 plus 7 plus 11 plus 16, it goes from a sequence to a series. Now, just like with sequences, we like to write them as a formula instead of a long list of numbers. We can do the same thing with series, but we need to do something a little bit different, and that's using this Greek letter sigma. So this is called sigma notation, or summation notation. They're really the same thing, but we're going to use the word sigma. So sigma notation is used with a rule as a way of defining series. So this is sigma notation right here. All right, and the way you read this is it's the sum of 2n as n goes from 1 to 5. Okay, and there's some important elements here. So this index of summation is just telling you what your variable is. The number next to it, so it starts with n equals 1, this number is the first value of n that you use. The number up top is the value of n that you go up to, so the last value of n. And then this expression here, sometimes it'll be in parentheses, is the formula for the terms of your series. So let's go through and practice this. So it's asking us, write the series given the summation notation and find the sum of the series. So this sum is telling me to find the sum of 3n as n goes from 1 to 4. All right, well, let's start. First I say n equals 1. All right, then plug in 1 for n. That's 3 times 1. Okay, so my first term is just going to be 3. All right, my next term, I'm going to make n 2. So just increase n by 1 each step. So n equals 2, well, that's going to be 3 times 2. Just plugging 2 into this formula here. That's going to be 6. Plus n equals 3. It becomes 3 times 3. Well, 3 times 3 is just 9. And then I have n equals 4. And that's where I want to get to, because my upper limit, my last value of n, is going to be 4. So n equals 4 is the last one I have to find. So I got 3 times 4. 3 times 4 is 12. So then, should be a plus sign. Be careful with your notation. All right, my answer then is going to be these things added together. Well, 3 plus 6 is 9, plus 9 is 18, plus 12 is 30. So my answer is 30. So this sum here has a single value. It's just 30. We can express it as a series. All right, let's look at one more example. This says the sum of n plus 2 as n goes from 2 to 6. So let's write that down. So start where it says to start, n equals 2. Plug that in. 2 plus 2, well, that's just 4. My first term is going to be 4. Then I go up by 1, n equals 3. Plug 3 in, I got 3 plus 2. That's just going to be 5. Have n go up one more value, n equals 4. That's going to be 4 plus 2. I get plus 6. My next value is n equals 5. Okay, plug 5 in for n. I get 5 plus 2. It's going to give me 7. And then my last value, because I finally got to 6, is going to be 6 plus 2. That's 8. So then my answer is going to be the sum of 4 plus 5 plus 6 plus 7 plus 8. Well, 8 plus 7 is 15, plus 5 is 20, plus 10 is 30. So this one's equal to 32, which is pretty interesting. Now try some practice problems and see if you can figure out how this works.